Today we will solve some problem. Give me a minute. एक बार और ग्रुप में डाल दे राजू. The maximum wavelength of radiation that can produce photoelectric effect answer. You can send an answer to chat faculty.
सर आवाज नहीं आ रही। One minute connecting again. And got disconnected.
Am I audible now? अब आ रहा है आवाज?
Yes sir, थोड़ी धीमी आ रही।
इसमें कोई डाउट तो नहीं है किसी को? Anyone have problem in this question? बच्चों आवाज आ रही है ना? राजुल ये भी काम नहीं कर रहा है भाई। तो इधर कोई यस नहीं बोल रहा है ना? अब आ रही है। Am I audible?
Yes, sir.
Okay. Very easy. This question was very easy. Now let's start. Next question. In the last class, I told you about various graphs or not? So, what will be the nature of graph if we take kinetic energy on y-axis and frequency of incident radiation on x-axis? To use this equation to draw graph. At the place of hc by lambda, can I write hf minus work function, right? Now let's compare this with y is equal to mx plus c. So the slope is h and the y-intercept is minus 5. So the nature of graph should be like this. Understood? Any doubt? This portion is work function. If you take kinetic energy on y-axis, then the negative intercept is actually work function. And we should draw this portion of graph like this, because electron will ejected after this. And this particular frequency is known as cutoff frequency or minimum frequency which can eject electron. Right. So do you remember name of this frequency, bacho?
Cutoff frequency.
Cutoff frequency, because after this frequency only electron will get ejected, and the slope is h. Slope is h. Sorry, Planck's constant. Understood? Everyone understood this graph? हेलो, फिर से आवाज नहीं आ रही राज?
सर आ रही है बस थोड़ा सा वो स्लो आ रहा
राजुल नहीं, इसमें ठीक से नहीं हो रहा है। वही वही दो, वही चल रहा था, ये ठीक से नहीं चल रहा। अरे वही दे दो तुम वायरलेस। इसमें कोई डाउट तो नहीं है ग्राफ में?
है।
ग्राफ समझ आया सबको?
Yes, sir.
यस सर।
इसमें वो जूम अटका था भैया, वो तो ठीक है। गिव मी 1 मिनट बच्चों। अभी क्लियर आ रही है आवाज?
यस सर।
ओके, चलो अब अगला क्वेश्चन करते हैं। थोड़ा केयरफुली इसको हैंडल करना। अच्छा ये याद रखें आप, ठीक है? मग अप दिस, रिमेंबर दिस, ओके? वेरी इंपॉर्टेंट ग्राफ for class 12th also. Next question. Both the lines should be parallel. Okay. This particular graph is given. First graph is for sodium and the second for aluminium. Now read options. Same threshold frequency means cutoff frequency, right? Have same threshold frequency means they have same minimum frequency to eject electron. Okay. Second is maximum kinetic energy for both metals depends linearly on frequency. Third option, the stopping potential are different for sodium and aluminium for same change in frequency. ऑप्शन थर्ड तो मुझे समझ ही नहीं आया क्या है. Okay. Answer. Which one is correct? Hello. बताइए कौन सा सही है. देखो फ्रीक्वेंसी सोडियम के लिए कम है और एल्यूमिनियम के लिए ज्यादा. तो कम फ्रीक्वेंसी में सोडियम से इलेक्ट्रॉन निकल आएगा. राइट. तो फर्स्ट और फोर्थ रॉन्ग हो गया. फोर्थ कहता है कि एल्यूमिनियम ज्यादा अच्छा फोटो इलेक्ट्रिक एमिटर है. गलत है. ज्यादा आसानी से इलेक्ट्रॉन तो सोडियम से निकल रहे हैं. तो सोडियम ज्यादा अच्छा फोटो इलेक्ट्रिक एमिटर हुआ. और थ्रेशोल्ड फ्रीक्वेंसी सेम नहीं हो सकती. सोडियम के लिए कम है, उसमें से इलेक्ट्रॉन पहले निकल जाएगा. Am I right? अब मैक्सिमम काइनेटिक एनर्जी डिपेंड्स ऑन फ्रीक्वेंसी ऑब्वियसली. Just we wrote that equation. Do you remember Einstein photoelectric equation? Maximum kinetic energy is equal to HF minus work function. So yes, maximum kinetic energy depends on frequency linearly. It is correct. Understood, bachcho? Second is correct. Can anyone explain why they are parallel? Why graphs is parallel?
Because their slope is h.
No, now slope is not h. Wrong. Let's make it a question. Find slope of given graph. Question number 3. What is slope of stopping potential versus frequency graph? But you draw this graph. I believe you remember what is stopping potential. Tell me how it is connected with maximum kinetic energy.
Stopping potential.
What? मुस्कान, come on. एक बच्चे ने जवाब दे दिया, साला कोई और जवाब देना ही नहीं चाहता. अबे क्या कर रहे हो तुम लोग? पढ़ लिख के आया करो. एहसान करने आते हो क्या? सीरियसली बहुत मतलब बहुत गलत है ये तो. नॉट. अब क्या करें? कुछ नहीं कर सकते. बेशरम भी हो तुम लोग. शर्म नहीं है. मैं चिल्ला रहा हूँ, आंसर मांग रहा हूँ, साला बैठे हो चुपचाप. So at the place of kinetic energy, you can write E into stopping potential. Keep stopping potential here. You can send E other side. So now if we compare this equation with y is equal to mx plus c, y-intercept will become equal to phi by e minus phi naught by e, and slope will become equal to h by e. So we make a graph. The nature of graph is still same. Nature of graph will look same, but there will be a difference in the y-intercept. Now y-intercept is phi naught by e, and the slope is not h, it is h by e. Now you use any metal, the value of h and e will be same for all types of metals. Am I right? For any type of metal, the value of h by e will be same. So if you draw graph for different metals between a stopping potential and frequency, all graph will be parallel to each other, but there will be a small difference in every graph, and this difference will appear here. If threshold frequency will be different for different metals. For some metals, it will be small, and for some metals, the value of threshold frequency will be more. Could you understand that? Could you understand that, Bacho?
Yes, sir.
Okay. Now let's move towards our next question. It is in integer type. Give me 1 minute. We didn't let's solve another question based on the graph. The figure shows the result of an experiment involving photoelectric effect. The graphs A, B, C, and D relate to a light beam having different wavelengths. Select correct alternatives. With the help of this question, we will understand one more type of graph. See this, on the y-axis we have current, obviously photoelectric current, and on x-axis we have accelerating potential. I hope you remember that experiment, in which in that experiment we try to stop fastest moving electron by generating negative potential. Do you remember? एक मेटल था, उसमें लाइट आ रही थी तो इलेक्ट्रॉन बाहर आ रहा था, right? I believe you remember that experiment. See 4 types of graphs given like this. This is A. This is B. This is C. And D. 4 different graphs. these 4 different graphs for different wavelengths. Okay. Now see options. It is more than one correct. Okay. This question is more than one correct. The first is beam B has highest frequency. Second, beam C has longest wavelength. Beam A has highest rate of photoelectric emission. And highest momentum is possessed by some electrons emitted by B. बताओ बच्चों, it is more than one correct. Read question properly. There is a metal plate, and on this metal plate, we are illuminating different radiations. Okay, 4 different radiation A, B, C, D. So which options are correct? Ganesh is saying B, C, D is correct. Nitish saying 2 and 3 is only correct. Aman saying 3 and 2. Most of the students saying 2 and 3 correct. Anvit, as usual, not giving answer. Other student, Pranamya not giving answer. Avni not giving answer. Okay. Sorry, I cannot give you more time. Now see which beam has a maximum stopping potential. Like 4 beams are coming on a plate. Imagine 4 different beams will incident on this metal plate. When light beam B incident on this photoelectric effect, the electron ejected, suppose this is electron ejected, and it has very high kinetic energy. It has very high kinetic energy because to stop this electron, you need maximum negative potential. You look at this negative, look at this negative potential. It is maximum for B. Means this electron is coming fastest. And why this electron will come fastest? Because incident energy is very high. अगर हम इंसिडेंट एनर्जी बहुत बढ़ा दें तो इलेक्ट्रॉन बड़ी आसानी से बाहर निकलेगा और बहुत तेज चलेगा, है ना? If kinetic energy is high, means stopping potential is also high. On same plate, these 4 different radiations are coming. So for B, I can see, as I can see for B, the negative potential is maximum. The stopping potential is maximum. Means kinetic energy of electron coming out due to beam B is fastest. Because beam B has maximum frequency. So A is correct, 100% correct. No one saying about anything about A. A is 100% correct. Beam B has highest frequency. Means beam B has highest energy. Right? Now let's talk about beam C. Beam C has longest wavelength. Longest wavelength means smallest frequency. Could you understand that? Now stopping potential is minimum for C. As you can see, stopping potential is the minimum for C. Means frequency of beam C is minimum. Means wavelength is maximum. So second is also correct. ये दिक्कत है. आप अगर सेकंड को सही बोल सकते हैं तो फिर फर्स्ट को कैसे नहीं सही पहचान पाए, राइट? आप ठीक से कर ही नहीं रहे. चलो खैर. Third, beam A has highest rate of, yes, because photoelectric current is maximum. So third is also correct. And fourth, the highest momentum is possessed by some electrons emitted by B. Yeah, 100% correct because they have maximum kinetic energy. If the electron emitted by B has maximum kinetic energy, they will have maximum momentum as well. All are correct. All are correct. Done? Any doubt? आगे बढ़े. Click on yes or no. Any doubt? आगे बढ़े. Okay. Thank you everyone. Thank you. आगे बढ़ते हैं. All right. Question number 5. It is from IIT Advanced 2015. This is also more than one correct. Very important graph. टच कर दिया ग्राफ ने एक्स एक्सिस को. As you can see that. There's more than one correct. I think you should take help of this equation. E into stopping potential is equal to hc by lambda minus work function. So you can write stopping potential is equal to hc by E lambda minus work function by E. So now if you compare this and you assume lambda as x and stopping potential as y, because you are taking stopping potential on y-axis and lambda on x-axis in 1 and 2. Look at graph 1 and 2. So you can write it like this: m upon x minus plus c. So what should be the nature of graph? Straight line or rectangular hyperbola? Tell me.
Fourth one.
Out of 1 and 2, look at only 1 and 2, I said.
Okay.
On x-axis, see what we are taking. What is there on x-axis? Lambda. So at the place of lambda, I am assuming x. I am not assuming x at the place of 1 by lambda. I am assuming x at the place of lambda. Please try to understand. And lambda की जगह x लिखा है मैंने. तो अभी 1 और 2 देखोगे, 3 और 4 नहीं देखोगे अभी. जब मैं 1 by lambda की जगह x लिखूंगा, तब आप 3 और 4 देखोगे. तो out of 1 and 2, कौन सा सही हो सकता है? Out of 1 and 2, it cannot be straight line. Inverse relationship है, फिसल पट्टी होगा. Do you understand that? बहुत गांव वाली लैंग्वेज में ही बात करना पड़ेगी. रेक्टेंगुलर हाइपरबोला आप लोग को समझता नहीं है, right? So it should be rectangular hyperbola. This is wrong because there is an inverse relationship. If you increase x, y will decrease. Could you understand that? So if we are increasing lambda, v naught is decreasing. Could you understand that? Okay. Now in this situation, we will take 1 by lambda as x, hc by E lambda. I should write into 1 by lambda separately. Now I'll write 1 by lambda as x, so and y at the place of stopping potential is equal to mx plus c. Why? Because this time I am considering 1 by lambda as x. That's why I'll get equation look like this. Do you agree? So out of third and fourth, which one is correct? Out of third and fourth,
Third.
third is correct. This was the question from IIT Advanced 2015. What an easy question, right? Easy है या नहीं है? बोलो श्रेया. नहीं है easy. Now write integer type questions. पहला क्वेश्चन है, the work function for potassium is 3 electron volt. If light having wavelength (2475 Armstrong) falls on potassium, find stopping potential in volts. Work function for potassium is given. Wavelength of incident radiation is given. They want stopping potential. I think you should use this equation. E into stopping potential is equal to hc by lambda minus work function, right? So E into Vs 12400 divided by lambda 2475 minus 3. So when you solve this, you will get E into work function is given 3 electron volt, right? Okay. By mobile, calculate and tell me what is value of this. Bacho, please anyone calculate this.
Approximately 2.
How much?
Approximately 2.
Are you mad? 12,400 divided by 2475 approximately 2.
5.010.
5.010 minus 3. So approximately 2 electron volt. E into Vs. So E will get cancelled. So stopping potential is approximately 2 volts. Understood, bacho? So answer of first integer type question is 2. Ready for next? Ready for next question? Okay, click on yes. Okay. Question number 2 is very good. There is a silver sphere, bacho. Silver sphere suspended by an insulating thread in free space, and its work function is 4.7 electron volts. Okay, it is under continuous illumination of 200 nanometer wavelength light. Incident radiation has wavelength 200 nanometer. Understood, bacho? As photoelectrons are emitted, the sphere gets charged and acquires a potential. As photoelectrons are emitted, the sphere gets charged and acquires a potential. The maximum number of photoelectrons emitted from a sphere the maximum number of photoelectrons emitted from a sphere is A into 10 to the power Z, where A is between 1 to 10. Find value of Z. Read question first, 2-3 times. You need to read it. I want to give you a hint. As electrons are coming out from the silver sphere, it will start acquiring positive charge. Am I right? And as the sphere gets positively charged, now it will become very difficult for electrons to come out after some time. Am I right? After some time, when it gets sufficient positive potential to stop fastest emitted electron will not come out. Am I right? See, what is the energy of incident radiation right now? Divide 1240 by 200. How much you are getting? 6.2, right? Now 6.2 minus 4.7. How much you are getting?
1.5.
1.5. So what is kinetic energy? Fastest moving electron has. How much kinetic energy? 1.5 electron volt. Am I right?
Yes.
So after some time, a sphere will get 1.5 volt positively charged. So when a sphere will get 1.5 volt, the fastest moving electron cannot escape from the sphere. Am I right? See, sphere is getting positively charged slowly. Am I right, Sinchna?
Yes, sir.
So what will happen when sphere have 1.5 volt potential? In fact, fastest moving electron cannot eject from the sphere, cannot come out from the sphere, right? Okay. As you are taking electron, sphere is getting positive charge. Initially, the fastest moving electron has kinetic energy of 1.5 electron volt. From this formula, what happened? Give me a minute. I don't know why pencil stopped working. Give me a minute, bachcho. Pencil got disconnected. It is not getting connected. Why? Give me a minute, bachcho. You keep solving that question meanwhile. राजुल पेंसिल डिस्कनेक्ट हो गई कनेक्ट नहीं हो रही नहीं हो रही ना अभी तो इधर आया हूँ डिस्चार्ज हो गया आई थिंक डीप डाउन हो गया Anyone got answer? Do you remember KQ by R? Formula of potential KQ by R. And you can write Q is equal to NE. Radius of silver sphere is 1 centimeter. Sorry, bachcho, I forgot to tell you. Radius of silver sphere is 1 centimeter. Anyone is trying or not?
Yes, sir.
Radius of silver sphere is 1 centimeter. Now time is over. I will solve. Radius of silver sphere is 1 centimeter. And we can write by using this formula, maximum kinetic energy is equal to Hc by lambda minus work function. So you will get maximum kinetic energy or the fastest kinetic energy of the fastest moving electron, 1240 divided by 200 minus work function, that is 4.7. So you'll get 6.2 minus 4.7. We got 1.5 volt. 1.5 electron volt. So we talk about stopping potential, you'll get 1.5 volt. Means 1.5 volt can stop even fastest moving electron. Right? Ganesh, you are correct. Very good. So if a sphere require 1.5 volt potential, then electrons will stop coming out, right? When a sphere get 1.5 volt, electron cannot come out. Suppose maximum charge sphere has Q. Suppose sphere got Q charge. And we can write Q is equal to NE, do you remember? And potential we can write KQ by R. This potential should be equal to 1.5. K is 9 into 10 to the power 9. Q is NE. Divided by R is 1 centimeter, means 0.01 is equal to 1.5. So when you calculate this, you get N is equal to 1.04 into 10 raised to power 7. So according to question, N should be A into 10 raised to power Z. So Z must be equal to 7. Understood, बच्चों? कैसे करना है? Could you understand this?
Yes, sir.
Okay. Let's solve another very good. This question is from IIT Advanced 2011. So you can get a simple idea what kind of integer question is coming or will be coming in IIT exam from the modern physics. The level of question is very low. These questions are very easy, right? Let's move towards next question. A pulse of light duration 100 nanosecond is absorbed completely by a small object initially at rest. The power of pulse is 30 milliwatt. What is final momentum of object? Any idea? There is a small object which is initially at rest. इसने एक पल्स को एब्जॉर्ब कर लिया तो इसका फाइनल मोमेंटम क्या होगा? जो बच्चे भी YouTube में देख रहे हैं प्लीज लाइक करें, सब्सक्राइब करें और शेयर करें अपने दोस्तों के साथ. Help us in getting 1000 subscribers as early as possible. Done? Done? No answer. See what we can do. How much energy pulse have? Power into time. This is energy of pulse. Power into time. Right. 30 into 10 to the power minus 3 into 100 into 10 to the power minus 9. This is energy. This much energy this pulse have. Okay. And according to Einstein, we can represent energy by mc square. So energy upon c is equal to m into c, means mass into speed of light, and this is momentum of a light wave. This is momentum of any pulse. From conservation of linear momentum, this is momentum p, right? So energy upon c. So momentum is energy upon c. This momentum is completely transferred to the object. Energy is 30 into 10 to the power minus 3 into 100 into 10 to the power minus 9 divided by c. Now what is c? C is 3 into 10 to the power 8. Could you understand that? Solve this, you will get momentum as 10 to the power minus 17 kg meter per second. Understood, bacho? Okay, everyone understood? Click on yes. This question is from IIT Advanced 2013. Done? Ready for next? I will send you this file. Wait, next. This question is lengthy. It will take some time to solve. A metal surface illuminated by light of two different wavelengths, 248 nanometer and 310 nanometer. The maximum speeds of photoelectrons corresponding to these wavelengths are U1 and U2 respectively. If U1 by U2 is 2 by 1 and Hc is equal to 1240 electron volt, nanometer, the work function of metal is nearly. Fourth option is 2.5 electron volt. ये क्वेश्चन अगर बन गया तो समझो आपका फोटोइलेक्ट्रिक इफेक्ट कंप्लीट हो गया. Means when 248 nanometer light falls on the metal, the kinetic energy is 4 times as compared to the second case when 310 nanometer light falls on the metal surface. So you can make two equations with 4 times of kinetic energy and only kinetic energy. Then you can multiply by 4 and eliminate kinetic energy from the equation to find value of work function. Question is easy.
Option 1.
Option 1. And you are correct. Very good. Now this question is from IIT Advanced 2014. Sorry, but my pencil stopped working again. I don't know what is happening. Because it is discharged. कहाँ से सही करते हैं?
Bluetooth.
ब्लूटूथ कहाँ दिख रहा है?
ऊपर ही तो.
हाँ चार्ज है 36% है तो फिर क्यों डिस्कनेक्ट हो रहा है बार बार? बेवजह डिस्कनेक्ट हो रहा है बार बार. ओके. ऑप्शन नंबर 4 था 2.5 इलेक्ट्रॉन वोल्ट. चलो कैसे किया? आकाश ने बताया था ना आंसर. देखो kinetic energy is equal to hc by lambda minus work function. Let's use this formula 2 times. As you can understand, u1 upon u2 is 2 by 1. Means in case 1 kinetic energy is 4 times as compared to case 2. 1240 divided by 248 minus work function. And the next equation is Ke is equal to 1240 divided by 310. Could you understand that, bacho? Could you understand these two equations? To solve these two equations, you will get work function is equal to 3.7 electron volt. Okay? Any doubt in that? Any doubt in this? No. Okay. आगे बढ़ते हैं. Okay? This question is from IIT Advanced 2014. Okay, right. Next question. If we double frequency of incident radiation, then maximum kinetic energy will also become double. Less than double. Ke max will be more than double we cannot say anything. What is your answer?
Option C.
Who is this? Name.
Ganesh Krishna.
Very good, Ganesh. Extraordinary. You have very good mathematics. Kinetic energy will become more than double. See, this equation we know. Ke max is equal to hc by lambda minus work function. Or we can write h into f, which is f represent frequency. Suppose this is incident energy, right? Suppose work function is 2 electron volt and incident energy is 5. So kinetic energy is 3 electron volt. Now imagine another case in which frequency is made doubled, means incident energy made double. Work function is still same. So how much kinetic energy you are getting? 8 electron volt, means more than double. Understood or not? If we double frequency of incident radiation, the maximum kinetic energy will be more than double. Could you understand that? It is 8, not 6. Incident energy 5 electron volt, work function 2 electron volt. So maximum kinetic energy 3 electron volt. Work function is still 2, but the incident energy made double. So the kinetic energy became more than double. Understood? Everyone? समझा?
सर इसमें मैक्सिमम काइनेटिक एनर्जी मोर देन डबल हुई, अकेले काइनेटिक एनर्जी होती तो वो केवल डबल होगी।
अरे नहीं भैया, काइनेटिक एनर्जी जैसा टर्म कभी यूज ही नहीं करते, मैक्सिमम टर्म ही यूज करते हैं, आउटर मोस्ट इलेक्ट्रॉन के लिए ही बात करते हैं। We never use word kinetic energy, we always use kinetic energy, maximum kinetic energy. And with the maximum kinetic energy we relate the fastest moving electron. आइंस्टीन की फोटो इलेक्ट्रिक इक्वेशन ही आउटर मोस्ट इलेक्ट्रॉन के लिए लिखी गई है, समझे? अब आई थिंक आप लोग कोई भी मॉड्यूल सॉल्व करेंगे कहीं नहीं अटकेंगे। ये जो क्वेश्चंस मैंने कराए हैं बहुत अच्छे स्तर के क्वेश्चंस हैं, ग्राफ भी पूरे हो गए हैं, कोई दिक्कत नहीं है। बट फिर भी अगर आपको जरूरत है तो प्लीज आप व्हाट्सएप में मुझे बोल देंगे सर थोड़े उस क्वेश्चंस और करा दो, तो मैं अगली क्लास में क्वेश्चंस लाऊंगा। और अदरवाइज अगर इन द नेक्स्ट क्लास विल स्टार्ट wave nature of particle. Okay, de Broglie wave we'll start in the next class. Okay bachcho, today also Ankur sir is on leave, so today also you won't get organic chemistry, but we are going to start class 11th physical chemistry by tomorrow probably. Okay, so stay connected, please read WhatsApp message for any update.